Hey kids, Mr. Murray here. I'm Mr. Murray's Mathland, and we're continuing on with trig identities, and this video is all about the half-angle identities, which, if you've got to memorize them for your class, your teacher, they're not so bad. You practice them a little bit. But if you have, we're going to focus on having them in front of us and how to use them. That's, I think the harder part, of course. So the very first problem is when you might need something like this. Evaluating the sine of 112.5 degrees, and seeing that 0.5 degrees is a dead giveaway because that's half of a degree, that this is probably half of an angle that you do know how to evaluate, right? 112.5 is not on the unit circle, nor could it be broken up into a simple sum or difference, which is another identity we've worked with. So if you notice, these are all expressed as sine of u over 2, cosine of u over 2, tangent of u over 2, as an half of an angle. And then you use whatever that angle is in here, in the identity, right? Whatever that u is. So the idea is 112.5 is not a nice angle, but is it half of a nice angle, a unit circle angle? So off to the side, you might just be able to do this in your head, or you might have to, off to the side, say, this u over 2 expression that I'm looking for, we're going to let it represent 112.5, the sign that I'm trying to do, and basically just solve that for you. So multiply both sides by 2, and what is double, or 2 times 112.5? That would be 225 degrees, and that should look like a familiar angle to you. So sine of 112.5 is equal to sine of, and I'm just going to rewrite 112.5 as 225 over 2, right? 225 divided by 2 is still 112.5. Now I've got it in that format where 225 is my u value that I'm going to substitute in here into the formula. So before we get, plugging in, because formulas are great, we follow the formula, there is one piece of this that confuses people sometimes, and it's this plus or minus that happens in the cosine and sine formulas. You have to choose the plus or minus. And that is depending on what angle are you trying to evaluate. I'm doing all of this work. 225 is not the angle I'm trying to evaluate. It's the angle I'm using to help me evaluate this, the sine of 112.5. So ask yourself, 112.5 is in what quadrant? This is in quadrant 2. And in quadrant 2, sine is positive, right? Because of all students take calculus, right? Quadrant 2, sine is the only positive one. So that means that we are going to choose the positive square root of 1 minus cosine of u over 2. And that's the part where you have to do a little, thinking. So we're going to pick positive, not that you have to write that, I'm just writing it for emphasis here, positive square root of 1 minus the cosine of that u, and that u is 225, right? So I'm just plugging in that u value, right? 112.5 is half of 225, so that's what I'm using to get the job done. But 112.5, the angle is in quadrant 2, where sine is positive, and that's what told me to use the positive from the plus and minus. Again, I'm not looking at 225 and saying that's in quadrant 3 where sine is negative, and so I should have used the negative. No, we're using 225 to figure out this one. Okay, so maybe I've over-explained that, but still, it's a common mistake. So now, continue on, and now it's just kind of evaluate, be good with your algebra, right? Know your unit circle. 1 minus, what is the cosine of 225? Hopefully you're still pretty comfortable with those values. The cosine of 225 is negative root 2 over 2. That's quadrant 3, where cosine is negative. reference angle of 45 degrees. And so when you have that 1 minus negative, you get 1 plus root 2 over 2, and it's all divided by 2, and this is all happening on the inside of that big square root. And so we're just going to clean this up a little bit. One way to do it is to multiply the top and bottom on the inside of the square root by 2, just to multiply through by that LCD. And then, of course, that's going to make that be 2 plus root 2, all divided by 4. And then I'm going to not leave a big fraction inside of a radical. I'm going to break that up, square root of the top over square root of the bottom. 2 plus root 2, all inside one big square root, and divided by square root of 4. And square root of 4 I can actually reduce. So square root of 4 is 2. So that, after all that, is what the sine of 112.5 degrees is. That value right there. And of course, you're a little unconfident with some of these terms here. You can always check with a calculator just to develop a little confidence there. Sine of 112.5 is that decimal 0.9238, etc., which is the decimal equivalent of square root of 2 plus root 2, all divided by 2. So pretty cool, right? That you can use these things. Okay, so let's try a couple others here. What about if we're in radians? Similar thought process, but just to do an example with radians here. 5 pi over 12, that's not a unit circle value. Now some of you may be, if you're really sharp, you might say, I could do that one actually with a sum or difference using, pi over 4 and which would be 3 pi over 12 plus 2 pi over 12, and that would be pi over 4 and pi over 6, and you absolutely could. But we're just saying, how could you use a half angle for this? So you can also do half angles for denominators of 12, because again, 5 pi over 12 is not a nice angle, but it's half of a nice angle. It's half of 5 pi over 6. And again, if you can't, if you have trouble doing that in your head, you can always say u over 2 is equivalent to 5 pi over 12. So basically double that 5 pi over 12 to come up with the u value that you're going to use. And that is 5 pi over 6 when you multiply by 2, right? Okay, so the u value is 5 pi over 6. So cosine of 5 pi over 12 is equal to cosine of 5 pi over 6 divided by 2. However, before we jump in and start plugging away, think about this formula. Is it plus or is it minus that I'm going to use? That's the one part that requires a little thought and decision on your part. So remember, you don't use 5 pi over 6 to make that decision. You use this. The angle you're really trying to figure out is the cosine of 5 pi over 12, and that just requires a little thought on your part. 5 pi over 12, what quadrant is that in? 5/12 is less than a half, right? And here's 90 degrees is a half pi over 2. So you are less than a half. You are in quadrant 1. And in quadrant 1, everything is positive. So again, you're using the positive square root here, not the negative. Okay, so always look at the original angle there just to see that again. Okay, but now you're off and running, and you're going to see a lot of familiar algebra. It's almost the same formula as the sine half angle, except it's 1 plus cosine of your u value. Our u value is that 5 pi over 6. Now just simplify, be good with your unit circle, your algebra, your radicals. Cosine of 5 pi over 6 is going to be negative, so that's in quadrant 2, so I'll just take that plus away. It'll be minus, and the cosine of pi over 6 is root 3 over 2, all divided by 2. So again, I get this instance where I have a fraction of 2, so I'm going to multiply the top and bottom by 2, the LCD, to just cancel that. So that's going to be 2 minus root 3 all over 4. Break that up, take the square root of the bottom, the square root of the top, square root of the top. So one big square root of 2 minus root 3, square root of 4 in the bottom there is 2. And that is your final answer. That's what the cosine of 5 pi over 12 is. Check it out on a calculator if you don't trust yourself. Okay, last example here is another thing you can do is sometimes you use these in the midst of larger equations you're trying to solve. So check this equation out. Trying to solve this equation over the interval 0 to 2 pi, tangent squared is equal to sine of 2 theta over 1 plus cosine of 2 theta. And you could start to try to use Pythagorean identities over here. Make this be secant squared minus 1, and then try to change that into some cosine squared, and try to use some double angles over here. Could be a little messy, but it'll eventually get you there, I'm sure. But if you recognize that this is just the tangent half angle, we can go back and condense this down. So this is tangent squared of theta is equal to, now just be careful when you do condense this down, this will be tangent of u over 2, right? The u that's here, we get half of it when we put it inside of tangent. So the u is 2 theta, so I got to put that right here, and then I divide that by 2, take half of it. But that actually ends up working out pretty nicely, because now you've got tangent squared of theta is equal to tangent of 2 theta divided by 2 is theta. So it's actually nice when they have the same argument, because now we can just proceed and solve like we've been doing, and this should be pretty nice. So subtract tangent of theta, bring it all to one side. You've got tangent squared of theta minus tangent of theta equals 0. Factor out a greatest common factor. So I'm going to take out tangent of theta. Notice I didn't divide by tangent back there 2 steps ago. That's bad algebra. You'll be losing some solutions. But if you factor out tangent, the common factor, you have tangent times tangent minus 1. Set each factor equal to 0 and solve, right? So tangent of theta is equal to 0. Tangent of theta minus 1 equals 0. Where does tangent equal 0? That's, sine over cosine equals 0. So you're really saying, where does sine equal 0, right? When you have a fraction, the only way it equals 0 is if the numerator is equal to 0. So by now you should probably be pretty proficient if you get to this point of the unit with solving that kind of thing. But where does sine equal 0? That would be where the y-coordinate's 0 in the unit circle. So that would be 0 and pi. We're not including 2 pi if you noted the interval there, 0 to 2 pi, exclusive on the 2 pi. So we have 0 and pi so far. And now solving this second factor, you're saying when does tangent equal 1, positive 1 specifically, and that would be a reference angle of pi over 4, but tangent is positive in quadrant 1 and quadrant 3, right? From all students take calculus, that's quadrant 1, quadrant 3. So quadrant 1 would be pi over 4. The quadrant 3 would be just 1 bigger than the denominator, or pi plus that reference angle of pi over 4, giving you 5 pi over 4. So there are your 4 solutions. Check them if you like, all 0 to 2 pi, all good inside the interval. But you can always go back and check if you don't trust it. And so there we go, doing some half angles, a couple different things with them. If you have any questions, let me know, but hang in there and keep working hard with this stuff.